more probably that you didn't get to. Most people were doing like 1 through 5, but some of you skipped around some. Any 5 was fine. What is one you guys ran into and you're like, I'm not really sure what's going on here, you would like us to look at? I can't do all of them, but if you want to pick one that in particular was just confusing to you. I think one's a good one to look at here. So whenever you have tangent and secant, you cannot replace these with like Pythagorean identities because they're not squared, right? So like tangent squared plus 1 equals secant squared doesn't work here because these are not squared. So pretty much your only option that I can think of is to change things to sine and cosine, which if you're totally stuck and you have no idea what else to do, try changing everything to sine and cosine. It's my go-to strategy. It's what I'll try a lot of times. So here, tangent is going to be sine x over cosine x. And secant is 1 over cosine x. So on Wednesday, we're going to have an identities quiz. Make sure you're studying those. It's the first 2 slides from yesterday or from Friday's notes. And then there's going to be a few more that we add to it tomorrow whenever we do our part 2 notes. And Wednesday we'll have a quiz, but it's only memorizing the identities, not on actually using them. I'd love to give a quiz on that, but we got to get finished and start reviewing, so we're probably not quizzing. You'll just see these types of questions on the test. So multiply straight across. I will get sine x on the top. What do I get when I multiply cosine x times cosine x? Cosine squared x. Now, the question told me to write g of x as a fraction involving powers of sine x and no other trig functions. Now, does anything cancel right here? No. So that cosine squared is not just like going away because I can cancel it out right here. The key to this one, it comes from the Pythagorean identity, right? I know that sine squared x plus cosine squared x equals 1. That is the Pythagorean identity. We're all going to have it memorized Wednesday. We're going to write it down. We're going to get 100 on a quiz, right? But if I take sine squared x and I subtract it from both sides, I will get cosine squared x equals 1 minus sine squared x, right? So this is still true, right? Just moving that sine squared x over to the other side doesn't change the fact this is still true. So that means if I ever have a cosine that I really need to turn to, a cosine squared that I need to turn into something in terms of sine, I can use this identity right here. So what I can do is I can say sine x stays the same on top, and then I can change the bottom to 1 minus sine squared x. Now, look at what they were asking us for. Rewrite g of x as a fraction. Do I have a fraction? Yes. Involving powers of sine and no other trig functions. I've only got sine, right? No other trig functions. I have a power right there. And even though it's not written, like technically this is to the first power, so I have a power of sine there. I've got what they asked me for. So I'm going to stop, right? This is the answer. This is good. It's not going to simplify further because now Raleigh asked me a really good question before class, and I think that it's a good thing to point out. So I wouldn't write this down because the answer to his question was no, you can't do that. But I think a lot of people will have the same thought. So he said, can I do this? Can I cancel sine with one of the signs down here? And then I would just have 1 over 1 minus sine x, like that. That looks more simple, looks prettier, right? The answer to that question is no, you cannot do that. The reason is because when you're canceling those signs, there is a minus sign right here. Okay, things are separated out with addition or subtraction. What it's like is like if I had 2 over 2 plus 3, right? That equals 2 fifths. But if you do it the way that we just did, 2 over 2 plus 3, cancel those 2's out, I get 1/3. Is that correct, that second way? It is not. Okay, so if you have plus or minus signs separating out the stuff that's left, you cannot cancel for that. Does that make sense? Around the 1 minus sine squared? Yes. Yes. You have like implied parentheses around the numerator and the denominator. Yes. Okay. Questions there? All right. Anybody else? Anybody have one they'd like to look at? One in particular? I'm gonna do a couple of them, but you have one in particular you've tried and would like to look at? Oh yeah, we're not gonna do all of them, but I'm gonna do a few of them together, and then we'll have you guys work on the rest of them. 10? Yep. Let's go look at 10. Okay. For 10, do I have anything I can just replace right off right here? Like, can I use like a Pythagorean identity or anything? The only real thing I can do is change this. I could either do like cotangent could be 1 over tangent, or I could do all sines and cosines, right? My personal preference is sines and cosines for this. So if I change tangents to sines and cosines, I'm going to have sine theta over cosine of theta. And if I change cotangent, I will have cosine theta over sine theta. Okay. All right, what do you guys think now? Can I cancel the sines and the cosines? I cannot. Why can I not cancel here? We're not multiplying. There's a plus sign in between, right? So it looks a little different, but it's the same idea from the last problem where I told Raleigh he couldn't cancel. You can't cancel here because of the addition. If that was multiplication, if this was tangent times cotangent, we could cancel, right? But we can't cancel because of addition. All right. Any other ideas? I want to add them together, but can I add these together? What do I have to add fractions? Common denominators. So I cannot do like sine theta plus cosine theta over cosine theta plus sine theta. That won't work, right? I need a common denominator here. So what I'm going to have to do is like this denominator has a sine and this denominator has a cosine. And the only way that I can get a common denominator is to have a denominator of sine times cosine, right? So, like right here, I don't have a sine, so I would need to multiply by sine theta right here. But if I multiply by sine theta in the bottom, what do I have to do in the top? Also multiply by sine theta. Because what is sine theta divided by sine theta? 1. And if you multiply a number by 1, does it change its value at all? No. So you're going to change the way it looks a lot, but you're not changing its value right here. Over here, I've got a sine, but no cosine, so I need a cosine theta here. And so I need to multiply by cosine theta on the top as well. Because again, cosine over cosine is 1. And when you multiply by 1, it doesn't change the value of anything, right? So, sine times sine is sine squared. And cosine times cosine is cosine squared. And now I have common denominators, right? Denominators of these two fractions are the same. So when I have common denominators, like when I have 1/5 plus 3/5 right? I add the top, I keep the bottom the same and only write it once. So that I'm doing the same thing here. So I'm going to add the top, sine squared theta plus cosine squared theta over sine theta cosine theta. Now, I think we can all agree this looks worse than it did when we started. But does anybody see where we can go with this? What do you think, Avid? We can replace the numerator with 1 because sine squared theta plus cosine squared theta equals 1. Very good. So I've got 1 over sine theta cosine theta. Now, at this point, you might want to start looking at those answer choices up at the top because maybe this is there, but it's not an option. Do you see anything that you think we could get there? Do you have an idea? All right, what do you think, Saul? Which one? Very good. Secant theta, cosecant theta, because this is the same as 1 over sine theta times 1 over cosine theta, right? If I multiply it together, and 1 over sine is cosecant of theta, and 1 over cosine is secant theta, but it doesn't matter what order those are in, so you could call it secant theta, cosecant theta, and that is going to be G for that one. So there are several of these that common denominators is a strategy that you might want to use, trying to find those common denominators. However, I usually change everything to sine and cosines before I look for a common denominator. All right. What else do I want to look at? Let's do 9. All sines and cosines is an option on 9. That it will work. However, it does take a while if you do it that way. Does anybody see something I could replace right there? What? Cosecant. Actually not cosecant. Secant. It's because we have that identity that like tangent squared x plus 1 equals secant squared. Yeah, and it is one of the reasons, like, if you know them off the top of your head, you will be able to do these problems a little easier because it'll like jump out at you a little better. Now this is tangent squared x plus 1, and this one's 1 plus tangent squared x. Does that make a difference? That they're not in the same order? Not when you have a plus sign. If you have a minus sign, does it make a difference? Yes, very much so. But you have a plus sign. So this is secant squared. So I've got tangent squared theta over secant squared theta. All right, ideas from here. Yes, I would go to all sines and cosines now. But if you could do it from the beginning, but if you put these together where it's just secant, it makes it so much easier to deal with there. So now I would do sine squared theta over cosine squared theta divided by secant squared theta is 1 over cosine squared theta. What do we do when we have complex fractions? Dividing fractions is easy as pie. Flip the second and multiply. So I've got sine squared theta over cosine squared theta times cosine squared theta over 1. Can I cancel anything? I can cancel these cosine squares. I can cancel them because I'm multiplying in between, right? No addition signs, multiplying. And so I just get sine squared theta, and that one is answer choice D. Let's do 14. 14, you've got to do something that we haven't really ran into yet. Can I change, like, I've got sine theta plus cosine theta squared. Can I just change that to 1? I could not. It has to be sine squared theta plus cosine squared theta, which is not what I've got here. So what I've got to do here is I got to think about this. This is sine theta minus cosine theta times sine theta minus cosine theta. When I see that squared, right? And then I've got sine theta plus cosine theta times sine theta plus cosine theta. And I have to distribute here, right? So I'm going to distribute here. Sine times sine is sine squared theta. I'm going to get minus sine theta cosine theta. I'll get another minus sine theta cosine theta. And then I'll get plus cosine squared theta. That's all just for that first part, right? Which, if I want to go ahead and simplify, is sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. If you want to square, double square, right? We talked about doing that as like a shortcut. Square the first, multiply them together and double the middle, square the last. You can skip all the way from right here down to here. I'm okay with that. However, a lot of kids get confused square, double square in that, so you may need to write it out. We're going to do the same thing over here. We're going to have sine squared theta plus sine theta cosine theta whenever we multiply here. Then we'll have another sine theta cosine theta and then plus cosine squared theta. And so that's going to be sine squared theta plus 2 sine theta cosine theta plus cosine squared theta. So you don't necessarily have to show those first 2 lines that I have there, but you might need to if you have trouble square, double squaring that. All right, any ideas here? You guys see anything? Because we've just made this look way worse, right? Looks awful. What do you think, Ava? Okay, so the 2 sine cosine, or the negative 2 sine cosine and the positive 2 sine cosine, what will you get when you do that? 0, they go away. Yes, definitely do that. Now, look at what we've got left. I could put the sine squares together, but I think I'd rather not. Because look what I've got left. Sine squared theta plus cosine squared theta plus sine squared theta plus cosine squared theta. Does anybody see it? This is just 1, and this is just 1, and what is our answer? 2. Isn't that beautiful? It just goes all the way down to 2. It doesn't matter what angle you plug into it, it equals 2 every single time. 2 is E for that. I love the ones that end up like that. I don't like the ones like number 1 that look more complicated really than you even started with, but love these problems. Okay. Questions there? 15, mark that. I already told you, mark that one out. You don't know what you need to know to do that one. Let's do one of these that's an equation like number 18. Let's do one of those. And then I'm going to turn you guys loose to do some on your own. Okay. I've got this equation, f of x. I'm supposed to find the zeros. What do I do to find zeros of a function, no matter what type of function I'm dealing with? Move everything to one side and set it equal to 0. So I'm going to have cosine squared x minus sine squared x plus sine x equals 0. Now, you have already solved equations. It's what you were doing on that quiz that we just looked at during the warm-up, right? So if I had things that were squared, I moved everything to one side. I factored it if I needed to, right? Set everything equal to 0. But we can't factor this because I have a cosine squared and a sine squared. So cosine squared minus sine squared, is there anything we can replace that with? There is actually, but you don't know it yet. And I'd really rather not use it anyway. I'd not do it that way. That is exactly what we want to do, because just like I did for that first problem, sine squared x plus cosine squared x equals 1. We know that's a fact, right? So if I subtract the sine squared x from both sides, I know that cosine squared x equals 1 minus sine squared x. So when you have a problem that has like sines and cosines mixed together, especially if it's an equation where you're solving the equation for values, there's a good chance you're going to need to change one of them to sine or to cosine. I could change the sine squared to 1 minus cosine squared, but we want sines because of this sign right here. So I'm going to get 1 minus sine squared x minus sine squared x plus sine x equals 0. All right, anything I can combine here? I've got sine squared and sine squared. Those can go together. What do I get when I do negative sine squared x and negative sine squared x? Negative 2 sine squared x. So I got 1 minus 2 sine squared x plus sine x equals 0. And everything's already on one side, but I do have something I don't like right here. If I'm trying, because if everything's on one side, I need to factor, right? And I do not like to factor when my sine squared is negative, right? If the squared term is negative, it makes it harder to factor. Plus, these aren't in order, right? So I would move everything over here to the other side. All it's going to do is change the signs of everything, right? So I would write the 2 sine squared x first, then the minus sine x, and then the minus 1. So everything just changes signs when you move it over to that other side. Or you can think of it like you multiplied through by negative 1. Either one will work there. Now, on delta math, as you were looking through your solutions, I heard a few of you talking about the U that was there. They use it for everything. I don't usually use it unless it is something I need to factor. And when I did the problems, I used the X instead. But what delta math does is better, because this problem already has an X in it. So I really shouldn't use an X again. So what they're doing is they're like, oh, let's let U be sine of X. So they're saying, well, this is 2U squared minus U minus 1. That we could just factor like X method factoring, right? It is a little bit tougher because it's got the 2 in front of our squared term, but we're just going to do 2 times negative 1. That's going to give us negative 2. We are going to try to add to get the middle term, which is a negative 1. What numbers multiply to give us negative 2, but add to give us negative 1? Yes. Here, multiply to give us negative 2, add to give us negative 1. It probably needs sharp. Negative 2 and positive 1. There. But I'm not done. What have I got to do? What? We're factoring over here. So I divide by 2. Right. And so this will reduce to be negative 1. This one does not reduce. X goes on the bottom. So that factors into 2u plus 1 times u minus 1. And we really don't want the u's. We want 2 sine x plus 1. Sine. Is it not working well back there? Oh. Anybody have a pencil sharpener that Raleigh can use, and I'll go work on it in a second. Look, he's just y'all have some nice writing utensils that you're just handing over to Raleigh. There. Okay. All right. When I get here, what do I do? Set each one equal to 0. 2 sine x plus 1 equals 0, and sine x minus 1 equals 0. This is like the stuff from the quiz, right? It's really just that first step that makes it go in this section. And then so I've got 2 sine x equals negative 1. I'll divide by 2. Sine x equals negative 1/2. And over here, I'll just get sine x equals 1. And then I got to think about the unit circle. So sine is your y-coordinate. Sine is going to equal negative 1/2 here. Square root of 3 over 2. Negative 1/2. No. Sine's y-coordinate. That's the wrong spot. Not here. Right here. This is going to be negative root 3 over 2. Negative 1/2. And then right here at positive root 3 over 2. Negative 1/2. So those two spots are going to be 7 pi over 6 and 11 pi over 6. And then sine equals 1 right here at pi over 2. Okay, questions? All right, so what I'm going to have us do is I want you guys to work for